Thank you very much. It's great to see so many people here. What a wonderful crowd. So today I have a confession. I'm not a data scientist. No. And Sunny also has a confession as well. She was a data scientist, but she's not a data scientist anymore. Oh dear. So what I really want to talk today about, what we want to talk today about, is actually that intersection between data science and engineering. So I'm an engineer who's now working in a data science group, and Sunny was a data scientist who now works in an engineering group, actually building real applications. I know, scary. So to kick us off, Sunny is going to introduce what she does, and then I'll come back a bit later and talk about my thoughts on this area. So this is really that intersection between engineering and data science, especially in an organization like this, where the data science really matters, right? It's applied data science. It's not theoretical. You know, we're not research. It's not about papers. It's about making a difference to the business. So I'm going to hand over to Sunny.
Hello, everyone. My name is Sunny, like the weather, and I am a software engineer who used to be a data scientist. And today I will be talking about the crossovers between these two jobs and how becoming more technical completely changed my approach for data science. The Trade Desk has done quite a lot to bring data science and engineering closer together in the past few years. It all started by embedding data scientists into engineering teams so that they could work closer with product and engineering. And this is what took me to the digital out-of-home team. I was embedded in it. This is the team that takes care of all the ads you see on these beautiful screens outside, not just on Times Square, but everywhere. You might have noticed them. It was a small team, engineering team, and I was the first data scientist to join them. And as you can imagine, there were a few challenges in that. First of all, the area was new and ambiguous. Data was extremely sparse. And for me, the biggest challenge was they didn't exactly know how to leverage the skill set of a data scientist. And honestly, I didn't know how I can help them myself. I started thinking about the key differences between these two roles. And as a data scientist, my focus was mainly on testing hypotheses, getting insights, dealing with huge data sets of more than billion records scale. And normally, naturally, as a data scientist, I was using the one-two omnipresent in every data scientist's life, the notebook. I loved notebooks. They were easy to set up, quick to run. They were great. Until at some point they didn't. As I was in an engineering team, the pipelines kept increasing, and my notebooks couldn't keep up with that. So I was struggling to get code reviews. I was struggling to let the engineering know what I was doing. And they were struggling to see how my changes can be implemented into production. On top of that, I wasn't exactly thinking about reusability of my code, so I ended up repeating work all of the time and just changing my code slightly. So this is where I realized, actually, I have this team of excellent engineers. Why not take advantage of that? I can just build on top of what they've built. It was a steep learning curve. The pipelines were huge. The pipeline they built had more than 20 jobs, and it was processing data sets of billions of records daily. It took me quite a while to understand how everything worked end to end, but as I was feeling more comfortable with the code, I actually started using Git. It was great. Now, all my experiments were neatly sorted into Git branches. My code was reproducible, and the biggest one for me was I discovered the magic of prod testing. Can you imagine running things in the same environment the production runs? It was great. Nerve-wracking when I had to spend thousands of dollars, but it was great. As a quick example I don't think this is working, but okay. It's a quick example. As I was getting more comfortable with the end-to-end pipelines, I started easily noticing areas for improvement in the team. Like, they weren't exactly taking advantage of the full data. They weren't taking care of the missing values. And ranking, interest level ranking, was actually pretty basic. For them, the way they were thinking the values was that a screen that had 2 out of 2 cat lovers was of the same quality as a screen that had 1,000 out of 1,000 cat lovers, which we all know is not the case. So for my first project, I focused on set ranking. It was a very easy statistical problem. I just had to compare different population proportion confidence intervals, like Wilson or Agresti-Cool. And in theory, I knew some of them were better at handling extremes, some were more conservative, but in practice, I had no idea which one would work better. And my notebooks couldn't really tell me that. This ranking was part of almost every part of the production pipeline, so I couldn't just run it in a notebook. So this is how I ran my first prod test. I implemented my ranking methods. I added them to the production pipeline, and I ran my jar against production environment. And in a few hours, I had my answer. Not only did I know which ranking methodology was the best, but I could also tell them how much it affected performance, something that they would usually have to figure out on their own. Following the same conventions as them and the same structure made it very easy for them to review. And also, they didn't even have to understand what this fancy math meant, which they were very thankful about because they were quite scared of that formula. It improved collaboration quite a lot, and we quickly shipped that small change into production that would have probably taken a while to do in this big pipeline. As a conclusion, and I'll hand over to Rory, this story ended up with me becoming a software engineer. I know, sad, but I learned a valuable lesson. I learned how to collaborate with people that don't share the same job description as me. I learned how adopting the conventions they were using day to day were helpful in starting to speak the same language as them. And I increased not only my productivity, but that of the entire team as well. And I'll be handing to Rory.
Thank you, Sunny. So let me introduce myself. So Sunny's gone from a data science world into an engineering world and has shown you some of the challenges and opportunities there. And this is something that I'm going to come back to. I think that intersection between the two is the critical area. So let me introduce myself first. So I have a confession. I was in banking for far too many years, doing systems engineering, real-time systems, trading systems, all that kind of thing. I'm also a bit clumsy. This is me managing to break both my arms at the same time about 3 years ago. I don't recommend it. I have a cat, and I give tours of windmills in my spare time. So, lots of random facts. I'm a software developer, and I'd never done much machine learning or AI or anything before. But when I joined the trade desk, they asked me to join the AI research lab. So our AI lab is responsible for looking at what's coming next. What AI and machine learning techniques should we be looking at? Where are we going? What's the exciting new tech? Obviously, everybody's going to. If I say what's the new exciting tech, everybody here is going to say, "Oh, it's LLMs." But yeah, it is. But can you actually use them in prod? Good question. We'll come back to that one maybe. So Sunny showed a scary equation. Let me tell you about my first team meeting. My first team meeting, I went into the meeting and one of my colleagues showed this slide. Does anybody recognize it? It is for generative AI. It's not LLMs, but it is generative AI. Let's be clear, after 2 years, I still don't even know how to say it all, let alone what it means. But that doesn't matter. The key thing is we are all working on the same goal. but we come from different angles. So a data scientist role, if you're in a pure data science role, is about discovery, which is why notebooks are cool. Very quick iterations, examining the data, getting insights. That's great, right? It's exactly what you want. When you come from a software development background, when you're running a trading system, I don't want to get called at 3 in the morning. I want stability. I want it to produce the same answers every time. In data science, apparently if it's right 70% of the time, that's a win. I still don't get it. I worked in trading systems where, the new release had to produce exactly the same numbers as the previous release. Otherwise, a whole bunch of people would spend a lot of time looking at it. But both sets of people are looking for business value, right? We're both trying to improve the business. Data scientists get better predictions. We're better, in our case, at placing ads, the right ad at the right time to the right person. From an engineering point of view, I need to be able to serve 15 million requests a second with 100 millisecond latency, 24/7, 365, right? But actually at the trade desk, we need to do both at the same time, right? It's data science at the cutting edge. We are using, within that 100 milliseconds, we are making predictions, right? So you can't just, it runs and, I ran my notebook yesterday and it ran fine, and I run my notebook today and it doesn't work and I don't know why yet. Who's had that? I've had that. I love notebooks. They're awesome in some ways, but in other ways, they're completely unpredictable. Don't run notebooks in production. If you take nothing else from this talk, that's the one piece of advice to take away. So I'm going to briefly talk about some of the fun stuff I do. So one of the things we've been looking at as a team is graphs and graph machine learning. So our user behavior graph takes data from our bid stream. Now this bid stream is these 15 million events we're talking about, right? This is live data. We turn that into a graph, and that can be, which sites people are traversing, because that gives you information about the sites. That can be time, location, all the metadata you can think of. We turn that through graph machine learning into embeddings, and we can use those embeddings to produce, to train other models to do the things we've been talking about. Now, this is all great, right? It's all basic machine learning. Well, I say basic machine learning, I think it's quite clever machine learning, but the challenge for us as an organization, and the challenge for a lot of people, is these graph sizes are huge. When we're dealing with it, it's not 1,000 nodes or 10,000 nodes or 100,000 nodes. We're into the millions of nodes, and in tens and hundreds of millions of nodes. And then you get into the billions of edges. And here's where the engineering comes in. The systems break down. We experimented with some commercial graph databases. Our test set broke the databases. And that wasn't even a tenth of the data. There was no way that those tools would meet our needs. And also, we have, as I said, about 2 trillion rows of data, raw data a day. Just writing applications that process that data in a timely manner is a real engineering problem. It's not just, you just process the data, right? I've got something in Spark that runs. It's like, at this scale, you start to blow Spark up, right? You can't run a big enough cluster to run the data fast enough. So you end up trying to reduce scope, and this is where you get the crossover. So not all problems can be solved by data science, not all problems can be solved by engineering. Some of the problems I've faced, you come across the data science, you say, oh, we can sample that, and here's how to do it right. Right, I can sample it, but can I sample it right and get the right answers? No. So it ends up being a discussion, and this is the thing. It ends up being a discussion between data science and engineering. What I want you to think about is you're in this bubble, probably. That's casting names for people. But when you cross it over, don't just be a data scientist. Learn about your business, whatever you're doing, because the sweet spot is between the two. If you know a bit about the business, you can apply that to the data science you're doing. And the data science can help the business people understand their knowledge. right? Your job as a data scientist is to help the business person explain the data they have. Now, let's add a third circle though, the engineering. Don't be afraid to learn a little bit of engineering, because by combining all three, by knowing a bit of business, you don't need to be an expert, but you need to be able to talk to the business. Learning a bit of engineering, again, you don't need to be an expert, but knowing how to talk to engineers and express your problems and understand what they say when they say, well, we need to deploy this, or we need to version control this, allows you to collaborate effectively. So, closing thoughts. Think outside of narrow roles. Don't think of yourself as just a data scientist or just a software engineer or just a business analyst, right? Learn a bit of everything, because in that way you'll find the really interesting problems are in those intersections. Collaborate, talk to people. One of the biggest things I've taken away from what I've been doing here is talking to a huge amount of people across a huge amount of teams, and everybody has a perspective and everybody has input. Play to your strengths. Yes, you might be a great data scientist. Use that. I'm not saying throw it away. Or if you're a great engineer, use that. But work with those and rely on others. Collaborate with others to take both of what you're doing to the next level. And one last thought is each of these spheres have different languages. One of the things I've learned, as I said, that first slide that I put up that showed what the data scientists, how they thought about the problem, was in a language I didn't understand. So I've had to think a lot about knowing a bit of the language in each of these spheres will really help you. So, thank you very much.